Hi guys, this is Worm from Worms Maths Academy. I just went through the multiple choice special exam 2017. Now it's time to have a crack at the extended response section B. Okay, now I've got to go through this quickly because the other one took me 37 minutes, which is a bit long, a little bit brain dead, I think. Answer all questions unless otherwise an exact answer is required. More than one mark, sure, working. Something's may not be drawn to scale. Acceleration due to gravity is g 9.8. Okay. X on 1 plus x cubed. Find the equations of any asymptote to the graph y equals f of x. Just looked at it, I can't remember what it was. X on 1 plus x cubed. X on 1 plus x cubed. Okay, so that's got an asymptote at -1, and it's also got an asymptote at y equals 0. It goes through the asymptote, but yes, it does have one at 0 and -1. Okay, so equations of any asymptote. So x is equal to -1, and y is equal to 0. Find f dash of x and state the coordinates of any stationary points. Correct to 2 decimal places. Okay, so we're going to grab that, edit copy, go out, edit paste, highlight interactive define. Then we want to find ddx of f of x. Okay, simplify, set that equal to 0, solve. Take your calculator of complex. Okay, point, what did it say? Stationary points, correct to 2 decimal places, find f dash. Okay, so that's the first thing we've got to do. So f dash, -2x cubed minus 1 on x cubed plus 1. And f dash x is -2x cubed minus 1 on x 1 plus x cubed. What was it? It's annoying having to switch between two. 2x cubed minus 1 squared. Was that a bracket on the top? Yep. Okay, so therefore 0.79. And of course we want our y value. So then we just say f of 0.53. Okay, find the coordinates of any points of inflection of the graph of f correct to 2 decimal places. Now some kids don't know this, but if you go into graph and table, sketch the graph, analysis G solve, inflection, 1.26 and 0.42. .26, 0.42. Okay, do we have any other points of inflection? It's worth 2 marks. That's really weird. Okay, you could say f double dash of x equals 0. Therefore, x equals, is it f? 1.26. So that's your point of inflection. Okay, sketch the graph from -3 to 3 on the axis provided. Marking it. Okay. So we know we've got that. X is -1. We know y is equal to 0. That approaches that, it goes through 0, 0. Actually, we shouldn't assume that, but 0, 0. Analysis G solve y-intercept. Yeah, it is 0, 0. We've got 1.26, 0.42. 1.26, 0.42. That's a point of inflection. It's not our maximum. I just realized. 0.79, 0.53, 0.79, 0.53. Okay, so when it goes up like that, stupid graph. Okay. Special is all about momentum, and I think I've lost it at the moment. So that's our turning point, 0.53, was it? Yeah. 1.26, 0.42. So that's when our graph goes down, and then it slowly starts to go back up. Points of inflection, so that's there, 1.26, 0.42. Intercepts axes 0, 0, and then our other one. Okay, let's just see what our y value is when x equals 2. 0.22. So let's say there. So graph looks like that. You don't need to put a point in there. So we've got our all stationary points, points of inflection, intercepts with axes, labeling of their coordinates, any asymptotes labeled. Okay, that's all done. The region bounded by S, the graph of F, the region S bounded by the graph of F, the x-axis, and the line x equals 3. So that's going to be in here. You don't do that, obviously, but it's just for you to see where it is. Write down an equation involving definite integrals used to determine the value of a. The line x equals a. Okay. The region about x-axis and the line x is rotated about the x-axis to form a solid of revolution. The line x equals a, where it's between 0 and 3, divides the region into two regions such that when the regions are rotated about the x-axis, they generate solids of equal volume. So there's some value down here that makes these two things generate the same volume. Where I just drew it, it's probably going to be somewhere like here, but let's have a look. So the equation itself is f of x. So if we go pi times 0 to a, so there's 0, a is some point here, 0 to a, f of x squared dx is equal to a with a pi out the front. Oh, we don't actually need the pi because it's going to cancel when we divide it. So you could just go like that. Could have it as well. A to 3 f of x squared dx. Okay, hence find the correct value of a. So let's see if we can get what a is. I'm going to clear it all. So our integral from 0 to a, I'm going to go y because it's annoying. Okay, f of x squared, go there you stupid thing, f of squared dx equals, duplicate that, so go from y to 3, select all, solve for y, 0.976, so a is equal to 0.976, so 0.98. Okay, one question done. Helicopter is hovering over, is hovering at a constant height above a fixed location. A skydiver falls from rest, 2 seconds in the helicopter, so he's jumping out. The skydiver is a subject only to gravitational acceleration. Air resistance is negligible for the first 2 seconds. Let down would be a positive displacement. The distance in meters fallen. U equals 0, T equals 2, A equals gravity. So S equals UT, 0, plus a half AT squared, a half G times 4. So 2G, or 19.6 meters. Show that the speed for the skydiver after 2 seconds is U is 0, T is 2, G is A is 19.6. Sorry, it's 9.8. Displacement is 19.6. So V equals U plus AT. 9.8 times 2, which is 19.6 meters per second. That's our velocity. After 2 seconds, air resistance is significant, and the acceleration of the skydiver is given by that. Find the limiting terminal velocity that the skydiver would reach. Okay, acceleration equals 0 when we get to limiting terminal velocity. For terminal velocity, so G minus V squared on 100 equals 0. So V squared equals G on 100G. V is equal to, it's going downwards, so 14 root 5 meters per second. Obviously, we're going to have V is equal to the square root of 100G. Square root of 100 times 9.8. Oh, you stupid thing. 14 root 5. You could also have 10 root G, I guess. Okay, write down an expression involving a definite integral that involves the time taken for the skydiver to reach a speed of 30 meters per second. Okay, so what have we got? We want to find our displacement, and we know that our acceleration is that. Okay, so V dv dx, V dv dx. What are we trying to find? Time taken. So we know dv dt is equal to that, G minus 0.01 V squared. So dt is equal to G minus 1 on, because you have to flip it, 0.01 V squared dv. Okay, so if we want to find time is equal to now. Different integrals, time taken for the skydiver. Okay, so we know it took 2 seconds to get to 19.6. So our velocity is 19.6 to 30 of 1 on G minus 0.01 V squared dv. I think a lot of kids would have stuffed this up because they would have forgotten that it was already 2 seconds and the velocity was already 19.6 when this air resistance started. Okay, so 19.6, 30. Okay, let's have a look. Integral 19.6 to 30 of 1 on 9.8 minus 0.01 x squared dx plus 2. 5.800 to the nearest tenth of a second. 5.8 seconds. Write down an expression of definite degrees the distance through which the skydiver falls to reach a speed of 30. Find the distance giving your answer. 3 marks, 3 lines. Okay, distance. So we know v dv dx. Don't forget it's not just dv dx equals this. Acceleration is dv dt, or it's also v dv dx, which is really just, what is that, v dv dx, v, we know is dx dt, times dv dx, hence the dx's would cancel and we get dv dt, so that's why it's v dv dx. Okay, so v dv dx is equal to g minus 0.01 v squared. So dx, or x is equal to, divide that v across, flip it upside down, divide it across, so v on g minus 0.01 v squared dv. Okay, so what do we want to work out? Find the distance, giving it to the nearest meter. So we've got velocity, okay, to reach a speed of 30. Okay, so we've got x is equal to 19.6 to 30 v on g minus 0.01 v squared dv plus 19.6, which is how far he fell, 19.6 meters in the first 2 seconds. Okay, so 19.6 to 30. Let's just change this, move it down. Okay, what did I have? 9.8 minus 0.01 x squared on x. Did I just put it around the wrong way? I did. X. 9.8 minus 0.1 x squared dx plus 19.6. 119.99 x equals 119. What does it say? To give it to the nearest meter, 120 meters. Okay, 2 down. A brooch is designed using inverse circular functions to make the shape shown in the diagram. The edges of the brooch in the first quadrant are given by this. What? Those lines look straight. So this is our 3 arc cos, x on 2, and that's arc sine. It looks straight. It must be. Write down the coordinates, the corner point of the brooch in the first quadrant. Okay, so we just want to put root 2 into 3 sine inverse of root 2 on 2, which is 3 pi and 4. Idiot. That's the y value. So it's going to be root 2, 3 pi on 4, if I haven't stuffed anything up. Okay, specify the piecewise function that describes the edges in the third quadrant. So it's got to be reflected in the x and then reflected in the y for both of them. Okay, so f of third, I'm going to call it. X is equal to arc, negative 3 arc sine negative x on 2, negative 3 arc cos negative x on 2, negative root 2 is less than or equal to x, which is less than or equal to 0, and negative 2 is less than or equal to x, which is less than 0. I might just define it just to check and make sure. So, clear all, piecewise function, where are we? There, 3, bloody stupid trig, sine inverse, x on 2 for 0, is less than or equal to x, which is less than or equal to, get rid of that, stupid thing, root 2, and then 3 cos inverse x divided by 2, root 2 is less than x, which is less than or equal to 2. Define it as f of x. Go into here, make sure your calculator's in that. Put in f of x. So that's it sketched. Okay, so then let's do negative f of negative x, which is what we just did. Sketch it. Beautiful. Okay, given that each unit of diagram, find the area of the broach, give your answer in square centimeters, correct to 1 decimal place. Okay, so we want from 0 to root 2, 3 sine inverse x on 2, arc sine x on 2 dx, plus, and we want to times it by 4, root 2 to 2, 3 arc cos x on 2 dx, area equals, okay, so we've defined f of x now, so we can just use that. Integral 0 to 2, I wonder if this will work, f of x dx times 4, just do that first, times 4, 9.94, 9.94, is it in centimeters? I think it is centimeters squared. Don't need to put centimeters squared because it says give it in that unit. Find the acute angle between the edges of the broach at the origin. Huh? Angle between find the acute angle between the edges of the broach at the origin. Give your answer. Acute angle. So this one's bigger, so it's got to be this one in here. So let's find out what the gradient is at 0. The gradient of that is, okay, so d dx of f of x given x equals 1. Why am I doing 1? Well, it doesn't really matter. But if we do it at 0, it's probably, it probably makes more sense. So the gradient d dx of f of x given x equals 0. What? The gradient of f of x. Oh, it's saying it's undefined. Okay, let's just do it at 1. It's going to be the same gradient. What? It doesn't like the function, the hybrid function. Okay, so let's try, what was it? 3 sine inverse x on 2. 3 sine inverse x divided by 2 given x equals 0. Okay, so the gradient's 3 on 2. So m equals 3 on 2. Therefore, angle with x-axis is tan inverse 3 on 2, which is 3 divided by 2, calculator in degrees, 56.31. Angle with the y-axis is 90 minus that. $33.69. Angle between edges is 2 times that. 67.38, 67.4 degrees. So what we did, we found the gradient of this line, we found the angle in here, theta, we subtracted it to find out this angle in here, we'll call it alpha, and then we times it by 2 to find out what the angle is between those two things. Okay, the perimeter of the brooch is a border of gold. Show the length of the gold needed by a definite integral of the form 0 to 2, that, where A, B are real numbers. Find the values of A and B. Show the length of gold border. The perimeter of the brooch has a gold border. Okay, so we're going to have to use arc length. So f dash of x is going to be, so 3 sine inverse x on 2. When I derive that, that's going to be 4 on 4 minus x squared, between 0, and then we can't really say root 2 because it's not defined at that endpoint, but we'll say that anyway. The other one, arc cos, so it's going to be negative 3 on root 4 minus x squared. For root 2 is less than or equal to x, which is less than or equal to 2. Okay, so what can we do here? They're going to be the same thing, because when I square that, when I square this, and when I square this, they're going to end up being the same thing. So we can say f of x is just, it's 4 times from 0 to 2, the integral of 1 plus negative, positive 3, negative 3, it doesn't make any difference because we're going to square it. 4 minus x squared, square rooted, squared, dx, because that's our arc length formula, that's dy dx. Doesn't make any difference. Okay, so what form? 4 minus x squared. So if I square that, then I've got to bring the 4 in. Okay, so 0 to 2. I've got to square root it when I bring it in. So I'm going to get 2. That's right, isn't it? Yep. Plus, that's going to be 9. So I'm going to get 18 on 4 minus x squared dx. I've got to square it when I bring it in. That's backwards. Because if I take it back out, I've got to square root it. So that's going to be 16. And then it's going to be 9 times 16, which is the same as 8 times 9 times 2, 72, 144, on 4 minus x squared. Therefore, A is equal to 16, B is equal to 144. That wasn't easy. Had to think with this bit here. Okay, express that in polar form. Negative 2 minus 2 root 3. Square that, you're going to get 2. Square that, you're going to get 4. You're going to get 4 times 3, which is 12, 16. So that's going to be 4. So negative 2 minus 2 root 3i is equal to 4 cis. Okay, and the angle is going to be root 3 tan theta. This angle in here is root 3. 1, 2 root 3 it's got to be pi on 3, but because it's around here, negative 2 pi on 3. So for cis, negative 2 pi on 3. Show that the roots of that are that and that. Okay, z squared plus 4z, halve that and square it, plus 4, minus 4 plus 16 equals 0. Z plus 2 squared minus 2 root 3 I squared. Z plus 2 minus 2 root 3 I. Z plus 2 root 3 I. Therefore, Z equals negative 2 plus or minus plus 2 root 3 I, and Z equals negative 2 minus 2 root 3 I. Okay, express the roots of z squared plus 4z plus 16 in terms of that. That's a bit weird. Okay, so minus 2 plus 2 root 3 I, and then minus 2 plus 2 root 3 I. There are two things in terms of that. So this one here is just negative 2 plus 2 root 3 I. And this one here, that's also negative 2 minus 2 root 3 I, the conjugate of it. And I stuffed that one up because it's got to be in terms of negative 2 root 3 I. So I guess you could say that's negative z1, and this one is negative z1 or negative z2 bar. Okay, show that the Cartesian of the form that, or the relation that, is that. Okay, so mod z is equal to z minus 2 minus 2 root 3i. Okay, x plus yi squared is equal to, okay, x minus 2. Forgot to square root that. Start this one again because I just stuffed it up. So x minus 2 squared plus y plus 2 root 3 squared. Don't forget you don't need to worry about the I because these are just components like they give direction. Square both sides. X squared plus 2xyi plus minus. Oh, that's not supposed to be there. What am I doing? This is supposed to be, because it's just components, x squared plus y squared. X squared plus y squared is equal to x squared minus 4x plus 4 plus y squared plus 4 root 3 y, and then plus 4 times 3 is 12. That cancels with that, and that. Okay, so we get 4 root 3y is equal to 4x minus 16. When we leave that on that side, bring these to the other side. So we get y is equal to, why have I got a different answer? Okay, divide through by 4. So x minus root 3y minus 4 equals 0, as required. Okay, sketch a line represented by that. What the hell is that? So that's 0 and 2 minus 2 root 3i. 0, 2 minus 2 root 3i. Actually, it's better off probably just... If we let x equals 0, if we let y equals 0, we get x equals 4. If we let x equals 0, we get y equals negative 4 on root 3. What's negative 4 on root 3 about? Negative 4 root 3, negative 2.3. Okay, and plot the roots of those things. So I'm going to say, there's that one. Okay, plot the roots. What were the roots again? Negative 2 plus 2 root 3, negative 2 minus 2 root 3i. Negative 2 plus 2 root 3. What's there? That's there. So I'll say there's Z1, Z2, and we'll say this is, oh no, what do I need to say now? Okay, the equation line passing through the two roots that can be expressed as Z minus A, Z minus B. So the equation line passing through that, which is what am I thinking? X is negative 2. So passing through the two roots of that can be expressed as see, we did this really randomly, and I think that's got something to do with it. Because we're going to basically have one line here and points here and here. So Z minus A, Z minus B. So there are 2 points, A and B are complex numbers. A in terms of B so just say B is this over here, B plus 4, because it's been moved to the left. Let's leave that one for a while. Find the area of the major segment bounded by the line passing through the roots of that and the major arc of the circle, mod Z equals 4. So mod Z equals 4. It's got a radius of 4. Find the area of the major segment. Okay. What do we know that angle in there is? So the whole area of the circle, total. So the area is pi, 4 times 4 squared. So 16 pi minus the area of a segment. So that angle in there is 2 pi on 3 all the way around, because pi on 3 in there, so that's going to be 2 pi on 3. Just trying to think, what's the area of a segment? It's 1/2 r squared, 4 squared, 2 pi on 3 plus sine 2 pi on 3. 16 pi minus 8. Does it want an exact answer? 16 pi minus 8 to 2 pi on 3 plus, is it plus or minus? Sine 2 pi on 3. Don't want decimal, don't want that. Want that. Simplify. Got a feeling that's a minus. Yeah, it is a minus. Okay, so 32 pi on 3 plus 4 at 3 units. Is it a area squared? Why did I change colors? Okay, a particular line of vectors are given by that, and that. Just like the graphs of the path of the sketch below. That's nice. On the diagram, mark the initial positions of the boat and the jet ski. Okay, so if I put 0 into that, cos of 0 is 1, so I'm going to get -1 and then 3. -1, 3. And then that's r of b. 0, I'm going to get 1, 1. So that's going to be r of a. What direction are they going in? Let's put pi and 4 into them to see which way they're going. So cos of pi and 4, that's going to give me cos of pi and 4 is root 2 on 2. So it's going to be 1 minus root 2, so that's going to be going to the left. Oh, it's this one. Oh, hang on, that one's going to be going to the right, so I've got to work out what the y value is. R of A. Okay, so this one here, I know that that's going to be going either there or there, but the y value is more important. So 3 plus root 2 on 2, so it's got to be going up because our y value is increasing. This one, we've got to work out what our x value is because we've got to see what's going left or right. So 1 minus sine of pi and 4, which is root 2 on 2, which is 0.707. So 1 minus 0.707 is going to be somewhere over here, so it's going to be going, they're both going to be going the same way. Okay, for the first time, t is greater than the speeds of the boat and the jet ski are the same. Okay, so v, b of t is equal to -2 cos t. What's that going to be? Derive cos, you get negative sine, so 2 sine t. I plus sine gives us cos. Okay, and then v of a of t, was it? And j. Look, why has it got b and a? V of j of t is going to be negative cos of t, I plus, and the speeds are the same. V cos of t, what was the other one? Negative cos of t is going to be sine of t j. Okay, so we want the magnitude of this thing, which is going to be the square root of 4 sine squared t plus cos squared t. That's that one, and then this one is going to be the square root of cos squared t plus sine squared t. That looks like something we know. It's 1. So we want to work out when 4 sine squared t plus cos squared t is equal to 1. Therefore, 4 sine x squared plus cos x squared equals 1. Solve, we'll go from x constant. So it would be not 0 seconds, is it? It's going to be when t equals pi seconds. Okay, state the coordinates of the boat at this time. Put pi into both of them. Cos of pi is -1, so that's going to be 3. And sine of pi is 0, so it's going to be 3, 3. Write down an expression for the distance between the jet ski and the boat at any time. Okay, so I'll say RB minus R of J is so x component sine of t minus 2 cos of t I, and then what did I do? R of J, R of B minus R of J. So 3 minus 2, which is 1, plus sine t plus cos t. So plus 1 plus sine t plus cos t j. So the distance is RB minus RJ, and that is the square root of sine of t minus 2 cos of t squared plus 1 plus sine of t plus cos of t squared. Find the minimum distance. Okay, so I've got to chuck this in the cas. Okay, this is annoying. So the square root of sine of x minus 2 cos of x, I think it was, squared plus 1 plus, I think it was sine x plus cos x, plus cos x squared. Edit, select all, interactive calc diff, and then select all, I'll bring it there, equals 0, edit, select all, interactive advanced solve. Let's go. Why am I getting a general rule? Have I stuffed something up? Sine t minus 2 cos t all squared, 1 plus sine t plus cos t select all, edit, copy, edit, paste. Actually, it's just clear. Let's go back to the edit, copy, edit, paste, edit, select all, calculation fmin. Okay, so let's just go from 0 to 10. So the minimum distance is 0.33 kilometers. Another morning, the boat's position vector remained the same, but the jet ski are considered starting from a different location, which is that one where both vessels start at the same time, assuming the vessels will collide shortly after starting. Find the time of the collision and the value of A. So our x component, this is annoying having to go back, it was 1 minus sine t, is equal to 1 minus 2 cos t. Now y component is a minus cos t. That's equal to 3 plus sine t. Okay. Equation 1, equation 2. Okay, if we add them together, we're going to get, let's line them up the other way. So that was 3 plus sine of t, and the other one was a minus cos of t. So when we add 1 plus 2, the signs cancel, so we get 4 equals 1 plus a. Actually, in the first one, we can get rid of the 1s and the minuses. So we can say sine of t is equal to 2 cos t, and then we can sub that from 1. We can sub that into 2, so 3 plus 2 cos t is equal to a minus cos t. Well, actually from here, we could say sine and cos equals 2, so tan of t equals 2. T, tan is opposite over adjacent, so that's going to be root 5. So sine of t is going to be 2 on root 5, or 2 root 5 on 5. Cos of t is going to be root 5 on 5. So we can sub that into the second equation. So 3 plus sine t, 3 plus 2 root 5 on 5 is equal to a minus root 5 on 5. So a is equal to 3 plus 3 root 5 on 5. Find the time of the collision and the value of a. So a equals that when t equals tan inverse of 2. Oh, last question. Okay, a dairy factory produces milk in bottles and nominal value of 2. Okay, they're trying to confuse us here. 2,000 milliliters. To ensure the bottles contain at least nominal value, the machine fills the bottles dispensers normally 2005 and a standard. Find the percentage of bottles that contain at least the nominal value That milk correct to 1 decimal place. Nominal value. Okay, so mu is 2005. So we'll just say x is normally distributed 2005, 36. I think I added an extra 0. Okay, the probability that x is greater than 2000. Okay, interactive distribution, continuous, norm, 2000, infinity, 6, 2005, 0.7977. Oh, what? Find the percentage correct to 1 decimal place. Okay, so times it by 100, 79.8. Okay, bottles of milk are packed in crates of 10 bottles when the nominal value per crate is 20 litres. Show that the total volume of milk contained in each crate varies with a mean of 20, okay, and a standard deviation of that. So n equals 10 in a bottle. Let C equal a crate. So expected value of a crate is 10 times the expected value of x, which is 20050. The variance of x was 36, so 10 times the variance of x, because I got 10 different bottles, so it's going to be 360. So mu of C is 20050, and then the standard deviation of C is the square root of 360, which is 6 root 10. Is it all supposed? Yeah, supposed to show that. Find the percentage correct one of crates that contain at least the nominal. Okay, so we can say C is normally distributed with a 20050 and 360 variance. The probability that C is greater than 20,000 is equal to, okay, so we want this, put it 0 on the end. What was that again? That was 6 root 10. And that was 20,000. 99.6%. Got to be close to the end. Okay. Did I finish that? Yep. Okay, regulations are nominal value of that. Assuming the mean volume dispersed by the machine remains 2005, find the maximum allowable standard deviation of the bottle filling machine needed to achieve this outcome. Give your answer millimeters correct to 1 decimal place. Okay. So 99.9. So let n. Oh no, because it's going to say normal. Let's say A equal the new distribution. We know the probability that A, that's not an A is greater than 20,000. That has to equal 0.999, which is 99%. So you can say probability that Z is greater than A is equal to 0.999%. So therefore, A is equal to interactive distribution inverse norm. Go to the right, 0.999. So negative 0.3090. Okay, so we know negative 0.3090 is equal to x. what do we know x is? 20,000 minus mu, 20,050 on sigma. So therefore, find the maximal standard deviation is equal to 50, what? 20, or negative 50 divided by that. So 16.18. So sigma is 16.18. So so what am I thinking? That's the variance of S. That's the whole thing, but we need to work out the variance of okay. So variance of S is 16.18 squared. 261.79. So if we want the variance of x, we've got to divide that by 10, which is 26.18. So therefore, find the maximum of a bottle filling machine. So the variance of x is the square root of that. So divide by 10, square root, 5.1. So that's what the standard deviation needs to be per bottle. This was per crate, so this is per bottle. Divided it by 10. A nearby dairy factory claims that the milk dispensed in its 2-litre bottles, normally with a mean of that and a standard variant. When authorities visit the nearby dairy factory and check a random sample of 10 bottles, they find the mean volume to be that. Assuming that the standard deviation of 2 mils is correct, carry out a one-sided statistical test. Carry out a one-sided, okay, because it's less than. So let's say H naught is that mu equals 2005. H1 is that mu is less than 2005. So we can say, we'll call it M milk is an element of N. 2005 4. Okay. The standard deviation of this sample is 2 on root 10. The probability that M is less than 2004, given that mu is equal to 2005, is equal to interactive distribution, continuous norm CDF. Okay, lower is negative infinity, up is 2004. That was 2 divided by root 10. And that was 2005.0569. So that's our p-value. Okay, as the p-value is greater than 0.05, we should accept the dairy's claim that at a 5% significance level. Okay. Alright, I think we're done. That super hurt my head. Where in the hell was that question we didn't do? Okay, it's back here. Remember to make sure you check your decimal places and all that sort of stuff. I try and do it as I go along. Express the roots of this thing. So this has got to have something to do with it, because express the roots of that is just random. So I got negative, one of them is what is the significance of that? So if I said that A is 2 minus 2 root 3i, then this is going to be negative A, and this is going to be negative A bar. The equation of the line passing through the two roots of that can be expressed as z minus A, z minus B, where A and B are elements of C. So I say A is equal to x plus y, B is equal to x plus yi. So there, whatever A is, we'll say A is to the right and B is to the left. So if I said B is negative 4, then A, if they're equal, relative to this line, A is equal to x plus y. So say A is a point over here, and B is a point over here. So say that's A, so that's B. If B is 1, if A is 1, then B would have to equal negative 5. So negative 4 minus A. So B equals negative 4 minus A. What about if, let's get rid of all the stuff we don't need. Okay, what about if A was to equal 1 plus I? Then B would need to equal, B would equal to negative 1 plus I, so it's going to be negative 5 plus I. So if we said the same thing, B would equal negative 4 minus, if I did minus A, that would be negative 4 minus 1 plus I, which would give me negative 5, which is what we want, but we've got minus I, but I want it to be plus I. So that's going to be A bar, I think, because that won't make any difference with a 0. Okay, so let's just choose a random point and see if this works. So let's say 2, 2. So A equals 2i plus, what am I doing, vectors? 2 plus 2i, not j. Therefore, if I said B is equal to negative 4, so it's got to be, because it's there, that's going to be 4 to the right and 2 up, so I've got to go 4 to the left, so negative 6 and 2 up. So that minus 2 minus 2i, which is negative 6, plus 2i, which is what we want. So that's what b is in terms of a. How in the hell does that connect to that though? I can't see it right now, but that makes sense. So I think that is it. What happens if we try a negative one? So let's say a is negative 4, negative 2. A is negative 4 minus 2i. B is therefore negative 4 minus 4 plus 2i, which is going to give us negative 4. It's going to give us 0, and then minus 2i. So that's that, and then, yeah, perfect. So that must be our answer. I mean, this has got a connection, just like that one, because we said this was negative a, and this is negative a bar. What's the significance of the 4? Negative 4. I guess because the origin's there. Negative 4 there. B is relative to A, so it's negative 4 away from it always. Hopefully that's the right answer. Okay, that's the last exam I'm doing for this year. I think I've had enough. My brain's fried. And hopefully all these answers are right. Good luck with your exams. Yeah. This is Worm from Worm's Maths Academy signing off. I'm starting my own tuition company in Berwick next year, so you're welcome to come along if you're watching these videos, you're probably not doing Year 12 next year, so let your friends know. Alright, cheers, see ya.